Good morning to all. Today we are going to see about the concept which is used in the wireless communication, which is called the cellular concept. The name is frequency reuse. So from the name itself, we can able to understand that the frequency reuse. That means the frequency spectrum has been repeatedly used by many number of channels. That is the meaning of frequency reusing. Since we have divided the entire geographical radio coverage area into number of cells in the hexagonal shape, so the each and every channel in a particular cluster has the frequency which has been already used by the another cell in another cluster. That is the meaning of frequency reuse. So it is a concept of using the same radio frequency within the given area that are separated by a considerable distance with the minimum references to establish the communication. Why we have to go for the frequency reuse? Allows communication within the cell on a given frequency. So it is used to reduce the limitation of the power to adjacent cell, and it allows reuse of frequencies in the nearby cell. And so by allowing the reuse of frequency, we can able to accommodate the day by day number of mobile subscribers within the available limited spectrum. It uses same frequency for multiple conversation. So for example, here there is a notation. For example, if you consider that we have n number of cells which are all using the same number of frequencies, and if k is the total number of frequency, right? So k is the number of frequency available and n is the number of cells available. Then how can we calculate the each cell frequency? By dividing the total frequency with the total number of cells, that is equal to k by n. For example, if AMPS, that is advanced mobile phone services, if you consider this k is equal to 399, that means the total number of frequency component is 399 and the total number of cells is n is equal to 7. And then if we calculate by using this formula, the frequency per channel will be equal to 395 divided by 7, that is equal to 56. That means the each and every cell has the frequency component as 56. So what is the purpose of frequency use? It is used to allocate the group of radio channels to be used within the geographical area. It is called as the cell, right? So by limiting the coverage area to within the boundary of the cell, the same group of channels may be used to cover different cells that are separated by one another at a particular distance. So the process of selecting and allocating the group of channels for the cellular system within the system, it is called as frequency reuse or frequency planning. That means dividing the entire geographic area into number of clusters and assigning the number of cells within the cluster and assigning the frequency component for each and every cell within the cluster. With this process, it is called as frequency reuse or frequency planning, right? So this is a pictorial representation of frequency planning, and the bold boundary, it represents the cluster. This is one cluster and this is another cluster and this is another cluster, and each and every cluster it is having 7 number of cells, and the cells within the cluster has been named from A, B, C, D, E, F, G, and the same numbering has been repeated in the other two clusters also. What is the meaning for this one? Here the cell which is named as A in 3 different clusters will use the same frequency component. That is the meaning for frequency reuse. That is the meaning, right? So the actual radio coverage of the cell is called as, it is also called as footprint in technical. So here this is an example for 7 frequency reuse factor of 7. That means within the cluster we have 7 cells, another cluster has 7 cells, another cluster is also having 7 cells. Here we have 3 clusters which is having 7 cells each. So the frequency reuse factor is 1 by 7. So this is another representation of the frequency reuse with the color notations. So here this is called as one cluster, and this is all the another cluster, this is also another cluster. All the 3 clusters having the frequency reuse factors 1 by 7. So how we can able to accommodate the more number of subscribers by using the frequency reuse. This is an example comparison between the earlier telephone system and the nowadays cellular system. In earlier telephone system, only one powerful transmitter has been located at the highest spot in the largest area to cover all the geographic area and its subscriber. But that has been replaced nowadays in the cellular system. Instead of having the one powerful transmitter, many low power transmitter has been placed at a particular distance to cover the entire geographical area. That comes the concept which is called as frequency reusing. So in the earlier telephone system, the frequency band offered, for example, the frequency band assigned it offered 100 simultaneous conversation means nowadays the same 100 simultaneous conversation, by using the frequency reuse concept, it can be increased to 1000 because of the frequency reuse factor of 10, right? So 10 into 1000, that means 10 into 100, that is equal to 1000. So this 100 times simultaneous conversation has been increased to the 1000 simultaneous conversation by using the concept which is called as frequency reuse. So this is again the frequency reuse with the frequency reuse factor of 1 by 7. So here this is about the shape of the individual cell within the cluster. Though we can use the different shape for the cell in the cluster like square, equilateral, triangular and hexagonal. So our objective is to cover the entire region without overlap and with equal area. So the choice among these four are hexagonal cell. So because of the following features, we have preferred hexagonal cell as a shape for the cell in the cluster. It has largest area among the other. Fewer number of cells is sufficient to cover the geographical region when compared to the square, triangular and equilateral. So here the one of the peculiar property of hexagonal cell, it has a circular radiation pattern which is similar to the omnidirectional base station and in free space propagation. So that's why we have preferred the hexagonal shape. And within the shape, how to place the antenna? There are two techniques. One is called as center excitation and edge excitation. So the antenna can be placed at the center or it can be placed at the edge. So when using hexagon to model the coverage area, the base station transmitters are either in center of the cell or in the edge cell, right? So if the antenna is placed at the center, then it is called as center excited cell. If it is at the vertex, then it is called as edge excited cell, right? And the type of antenna with the radiation pattern used for these type of excitation is the omnidirectional antenna pattern is used for center excitation, and sectoral directional antenna is used for corner excited pattern. So this is the comparison between the shape which can be used for the cell. So this is the rectangular cell, and this is a triangular, and this is a hexagonal. So here among the three, A1, A2, A3 and A3 will provide the maximum coverage area. With the fewest number of cells, we can able to cover the entire geographical region. That's why when rather than the square, rectangular and triangular, the hexagonal shape is mostly used because of equal area, no overlap between the cells. And this is the concept which is used to calculate the capacity of the cellular system. For example, if we consider that the total tubeless channel is capital S, and so total number of channels is S, and the cluster size is N cell. That means we have this total tubeless channel has been divided in number of n number of clusters, and the number of cells in each cell is that is equal to k. How we can divide? So that we have total tubeless channel, we have total number of clusters also. So this channels has been divided among this n number. So S by n, that is equal to the number of channels in a cluster, and capacity of cluster. You know the you know that number of cells in the cluster, right? So cluster size also you know, that is n. So the capacity of the cluster is C is equal to k into n, which is equal to the total number of duplex channel. And here this is for the single time. If we repeated the same concept for covering the entire geographical area for many times, the total capacity of the entire geographical area can be capital C, that is equal to the multiplication of the replication factor with the capacity of the cluster, that is equal to Kn. So C is equal to m into Kn, which is equal to m into S. So how many times we have repeated the clustering, so that much time the capacity will also increases. And how to design the cluster size, right? So you can use this simple formula to design the cluster size, right? So in order to find the nearest core channel, what you have to do, you have to move I cells along the chain of the hexagon. For example, this is a center hexagon we have taken, means we have to move along the chain of the hexagonal. In this way you have to move. So to which how many times of cells you have to move, right? I cells along the chain. Then you have to turn 60 degree, and then you have to continue the movement in the counterclockwise direction, that is equal to for j number of cells. So I is equal to the direct movement for direct chain, and j is the number of cells that is after the 60 degree inclination in the counterclockwise movement, right? For example, if I is equal to 3 and j is equal to 0, then you can calculate the cluster size among the three, that is equal to, so n is equal to 19. And this is again how to calculate the connect between the adjacent cells without a gap. This is a formula I square plus ij plus j square, right? So by using this formula, the mostly used cluster sites are either 4 or 7 or 12. Already we have seen this. This is a 7 cell cluster, and this is a 4 cell cluster, and this is a 12 cell cluster, right? That's all. So in this class we have seen the fundamentals of the cluster and the concept frequency reuse. So next class we will continue the another concept which is used in the cellular concept. Thank you.